like we are all immersed in an ocean of chlorofluorocarbons. They are present on land, they are present on the ocean surface, they are present everywhere. And there was another set of data which said ozone depletion is happening and we do not know what are the causes. Now you know what these scientists did? Do you know the meaning of the word serendipity? Serendipity? Serendipity, please note down the word serendipity. The word serendipity means by chance, we really do not pursue that goal, but then in the process of working on something, we bump into something which is extremely important. By chance, serendipity. 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 Now, the serendipity is by chance. Now, what did these scientists do? They put together these two dramatically opposite, incoherent bits of information. They also adopted the black box approach, as I said. Now, one very important question, you need to ask in this context is, if something is not reacting, and it is present as it is, it is present as it is without undergoing any change, it means it is not reacting with the environment. If something is reacting, it cannot progress too far. It is overreacting, it gets stuck at a place, gets stuck on some work, and it just remains there. But this set of gases is something which did not therefore react. They were present throughout the globe. Right? This was one understanding which they secured. And another understanding was they also looked at natural variations in the case of ozone. They said if ozone is being depleted, it happens at a certain natural pace. But what we see in terms of depletion is much, much higher than what can be happening. Therefore, there is something artificial about it which is happening. Yeah. What the hell did you learn at the end of 1 hour? What will they be? Don't look at the black. Or artificially induced. Excellent. Please remember this. This is very important. What are the two freezers in this globe? The two freezers in this globe? Sorry? North Pole and the South Pole, or the locations? But what are those? Arctic and Antarctic. They are the two freezers. You must remember, I'm just waiting for the water to come in. Unless it's going to be floods, it's come. Oh, no. If I was to make a very foolish assumption, people on left side of the room are water efficient, which means like they store a lot of water. And based on that, my hypothesis is you don't need water for the next 2 hours. You need tea. That's a good one. Can I go and ask for it? Only because they may ask me for but there's a problem when you're asking for tea. So it means you can listen for longer time. So do we just go ahead? Yeah. So now, what did these scientists say? They said, look, now what we see in terms of those derivations are far beyond what can happen naturally. Then they asked an extremely important question which vexed them in the Nobel Prize. They said, they asked a very simple question, and that was by chance again. They said if these gases are present, one of you can have this water, identical. So now, they said if nothing is happening to these gases within the troposphere, how is the troposphere? Till what height is the troposphere? बाकी लोगों को भी पानी चाहिए होगा. What is happening to them within the troposphere? And that's where we are. What is the height of the troposphere from the surface of the Earth? It's just about 12 to 15 kilometers. 12 to 15 kilometers. Right? And within this small shell of 12 to 15 kilometers, there is this complete dynamics of gases, and so on and so forth. Beyond 12 to 15 kilometers, this is stratosphere. And what is so very unique about the stratosphere? Oh, here comes the water. Let us see what can happen to them you know, in the in the stratosphere. Now, what is so unique about the stratosphere? I'm sure one of you can answer. Sorry?
Presence of ozone layer.
Presence of the ozone layer, and then oxygen is not there. Let's take a
Reaction
shot.
of the oxygen molecule with the oxygen atom.
Can you hear it? Speak loud and
So reaction of ozone molecule with the ozone atom to form ozone atom to form ozone.
now why is that happening? Now let's set another small rule of the game, okay? Unless all of you speak, that is, even if one of you don't speak, I will get stuck with you for the whole day. Okay? So now that's that's a challenge. If you want me to go, so all of you should start speaking. Yeah.
So perhaps in the upper layer, the molecule may be breaking in the ozone atom.
You are brilliant, but then that breaking happens on account of
Energy get from the sun.
and what is that energy?
Energy.
In the form of
energy from the sun.
well, heat is one of them. What else can it be?
Ultraviolet rays.
Brilliant. Okay, now to summarize what we said for the benefit of all of us, the stratosphere is the place where there are very high levels of ultraviolet radiations, right? And these ultraviolet radiations, supposing, like let's say I start fighting with you, okay, I start hitting you and you start hitting me, okay, we start resisting each other. What will happen to our bodies? Temperature will go up now. And there is constant fight between you and me, let's say. Even if we don't bang and we start shouting at each other. In this stratosphere, the ozone molecules there are constantly fighting with ultraviolet radiations. Okay? Because they fight, there is very high temperature. Fighting here doesn't mean hitting each other. Ultraviolet radiations break oxygen, and the oxygen atom combines with another oxygen molecule, ozone is formed. Ozone is again struck by ultraviolet radiation, the oxygen molecule and oxygen is formed. This continuous reaction happens. Imagine if this reaction doesn't happen. Okay, if this reaction doesn't happen, ultraviolet radiations will come into the earth in very high levels. Okay? Now, if they can break even oxygen, ozone and so forth, it means there are very powerful ultraviolet radiations, and therefore what did our two, three scientists do? They said, can these gases really break when they reach the stratosphere? Right? Because of high ultraviolet radiations. We said, oh my gosh, this can be true. Because ultraviolet radiations can break the chlorofluorocarbons, and if they break them, they can release chlorine, and chlorine can immediately destroy the ozone layer, because it can take away that oxygen that is being released and form chlorine oxides and prevent the formation of ozone. There could be other natural processes also. And you know what did they do? Similar to this empirical evidence black box, they said, look, why don't we capture gases from the stratosphere in a balloon, bring it down on the surface of the earth, run gas chromatographs and find out what is the composition, right? And there they could very clearly find that the levels of ozone were much lesser than what they expected. Now they said, like, before they did this also, they said it is like, unprovoked Saurav scoring a 6 in all, and the provoked Saurav scoring much more. So they said, like, the depletion which we see cannot be on account of chlorine alone. It has to be on account of something else also. So they said that villain can be only bromine, which can deplete ozone layer to such high levels. So they said there should be high chlorine, bromine, and when they did the tests here, they were confirmed. So that was right. And how did they do it? They also followed a simple logical pathway, which is this black box approach, right? And this fetched them the Nobel Prize. So what did they do? They said, no, therefore let us not release these chemicals which are responsible for it. Let's try to trap them, let's try to destroy these chemicals. The bottom line, therefore, for us to understand is these phenomena are constantly being understood over a period of time. The understanding also changes over a period of time. In this context, it is very important for you to know yet another final one with which I will stop. Okay? and this talk is deliberate, otherwise we can go on and on this. But what is important for you to know is there is something called the contrarian philosophy. What is contrarian? What is contrarian? We are taking up some contradictory positions here, right? As the subject of science evolves, our thinking on the whole problem also changes. We assume, for instance, one of the best examples is of people who discovered the problem of pesticides causing cancer. They said, pesticides are responsible for cancer way back in the late 70s and so on. But then today we can say very clearly that pesticides alone are not responsible for cancer. Does this mean pesticides are not? Pesticides are. But then our thinking of it changes over a period of time. There are several people who say like even very high concentrations of pesticides don't have any impact on us. But that is only for one small set of a population. Another set of people can be, even if they expose themselves to very small quantities, it can have dramatic effects. But this kind of understanding over a period of time changes gradually to such an extent that sometimes we might encounter understanding which is totally contrary to our earlier understanding. But please remember, this is just a phase of learning, a phase of learning. With more and more understanding, with clearer concepts, our understanding of the problem changes and we are then able to understand it in its totality, which is extremely important. Right? Please remember. These are two of the critical things which I thought I should share with you about understanding of science. Right? And this I'm sure can be applied to every aspect of our life. Every aspect of it. I'll stop at this, okay? And I'll leave before you ask me to. Yeah? Why don't you raise a couple of other questions if you're interested? You should know that, there is a, the India Meteorology Department, which gives us our daily reports, has got an extensive network of stations all across the country. In the case of ozone depletion, we have got a network of stations again on every latitude of our country, every latitude. Because depending on the latitude, the ultraviolet radiation intensity varies. So people have planted machines, meters, which are called Dobson spectrometers, in every latitude. Information from these Dobson meters are all continuously received on a second-to-second basis. And they are brought together at the India Meteorological Department. And there, all this data is put together, and if you go to the ozone office there, you will see a printer which goes on 24/7 every second.
Thesis or research even by the global prize winners.
Yes. Absolutely. That has been the basis of it. Can I help you understand what is happening?
No, I have understood.
Yeah.
But my question is, will we be able to apply this approach in reality?
It is happening. That's what I wanted to say. After they kindly say, right? It is as simple as this, and I'm sure you yourself know what is happening, and let me try my best to pull out the answer from you. Okay. Supposing I told you that chlorine and bromine, listen, is from the refrigerants we use in our refrigerators, right? And that has got accumulated here. What do you think we can do about it? Loud and yeah, what do you think we can do about it? Loud.
So is it a condition of the ice?
No. We know this chlorofluorocarbon gases have accumulated in the troposphere, right? Because we have been using them in our refrigerators. I'm sure you are smart enough to say, what can we do about it?
So we can switch off the refrigerator during night, and that would we can control.
Okay, supposing I help you understand that the chlorofluorocarbon gases have either leaked out of the machine, okay, or like when they were being produced in the factories, they were all released, and therefore they have got accumulated. Right? Now we cannot do much about that by removing them from the atmosphere. Don't you think? And I'm sure this is at the back of your mind. Supposing we say that we will somehow prevent the release of these chemicals, right? You probably said that if you put it off, we imagine it is not getting released. No? Supposing we, yeah.
Later we can decrease that. If it is not required of 7 refrigeration points, we can take 3 or 4.
Beautiful. That will also help us save our electricity and so on and so forth.